All right, so I asked you to finish the multiple choice sheet for homework. So we run the second column. Base your answers to 10 to 14 on the diagram below that represents a 5 kilogram object. So we have our mass revolving around a circular track, a horizontal plane at a constant speed. Radius of the track, R, is 20 meters, and the centripetal force, Fc, is 400 newtons. I just had to look close to see the superscript. In the position shown, the object's centripetal acceleration would be, so here it is, centripetal acceleration, always center seeking, so it should be towards D. In the position shown, the object's velocity is directed towards which point? So it's going in the circle counterclockwise. So at this spot, if the force were to be removed, it would go this way towards A. The object's centripetal acceleration is what? Well, we know AC is equal to V squared over R, but we don't have V, so we can't find it that way. So you need to do FC is equal to MAC, because we have F and we have M. So AC is just equal to F divided by M, so 400 newtons divided by 5 kilograms. That should give you about 80 meters per second squared. Okay, and then the object speed. So now that you have AC, you can use AC equals V squared over R, and so V squared will equal AC times R. So 80 times 20 is 1600. Take the square root. It should be 40. If the radius of the track increased, the centripetal force would do what? So remember that Fc is equal to mv squared over r. If you make r bigger and nothing else changes, then the centripetal force should, the radius of the track increases necessary to keep should decrease. Just needed to make sure I read the rest of the sentence. 15 to 19 is based on the diagram below that represents a car of mass 1,000 kilograms. Traveling around a horizontal circle, radius 200 meters at a constant speed v of 20 meters per second. When the car is in the position shown, the direction of the centripetal acceleration, center seeking, so it should be towards C. The magnitude of the centripetal force, you have M, you have V, you have R, so Fc is equal to mv squared over R. V squared will be 400 divided by 200, which should be 2, times 1,000 should be 2,000. Should be choice C, assuming I'm not screwing it up here. 17, if the speed of the car were doubled, what would happen to the centripetal acceleration? So AC is equal to V squared over R. If you double V, that's going to get squared. So AC should be 4 times as great. Note 18 and 19 only have 3 choices. That's their way of saying, hey, idiot, don't pick choice 4. If the additional passengers were driving in the car at the original speed, the car's centripetal acceleration would do what? If you put more passengers in, it's going to do nothing for the centripetal acceleration. It would make the force need to get bigger, but nothing's going to happen to the centripetal acceleration. It'll stay the same. As the car moves from its present position to position X, what happens to the kinetic energy? So here's its present position, here's position X. Kinetic energy is equal to 1/2 mv squared. Nothing changes, constant velocity. You haven't thrown anyone out of the car, so it should be stays the same. Da-da, finish the multiple choice questions. Now I also asked you to do 2 from the textbook. And the 2 from the textbook were on page, whoops, I just dropped all my papers, are on page 571. Trying to find the edge of my page. There it is. Okay, so page 571. And the first one is number 26. And it says, a motorcycle stunt rider wants to do a loop-de-loo within a vertical circular track. The radius of the circular track is 10 meters. What is the minimum speed that the motorcyclist must maintain to stay on the track? Okay, so he's going to go up and around and come down, right? So here's the little motorcycle, the buddy. So when he's up here, he is hanging. upside down. Okay? And so what are the forces acting on them? We're going to do sum of the forces have to equal mv squared over r. And up here, the forces acting on them are Fg and the Fn of the track. So it'll be Fn, and they're both going to be positive because they're both going towards the middle because he's hanging upside down. And it says minimum speed, so he goes around this loop slower and slower, and as he slows down, this side gets tinier. So what on this side gets tinier? The Fn. So he goes slower and slower and slower. This gets smaller and smaller and smaller. When he gets to his minimum speed, it means this is 0. If he goes any slower after that, then the two sides will no longer be equal. The mv squared over r will be too tiny. The mg will be bigger. It'll pull him out of the circle. It will not end well. Okay, so now the m cancels, and you're looking for v, so v squared equals g times r is equal to 9.81 meters per second squared, and the radius was 10 meters. So 98.1, and you're going to take the square root and get something very close to 9.9 meters per second for v. All right, so that's number 26. Number 27 is the typhoon ride again. Okay, so in this ride, it says an amusement park ride consists of a large cylinder rotating around a vertical axis. People stand on a ledge inside. When the rotational speed is high enough, the ledge drops away and people stick to the wall. The period of rotation, t, is 2.5 seconds, and the radius, r, is 2.5 meters. What is the minimum coefficient of friction required to keep the rider from falling? Okay, so here's my rider. Fn is going to be going in, Fg is going to be going down, and friction is going to be going up. What will this tell me? This will tell me my speed, because remember, speed is equal to 2 pi r over t. So 2 pi times 2.5 meters divided by 2.5 seconds. So my speed is really 2 pi meters per second. I could get a number for that, but it wouldn't be pretty and it wouldn't be round, so I'm going to leave it. So now we go some of the forces in the y direction, perhaps, and in the y direction he's sticking to the wall, so friction should be equal to Fg, which means friction should be equal to mg. Can't find it because I didn't give you a mass. So now we go to some of the forces in the x direction. That should be equal to mv squared over r. And in the x direction, it's Fn is equal to mv squared over r. Can't find it because you don't have the m. But what we do know is that friction is equal to mu Fn. So that means mg is equal to mu mv squared over r. The m's will cancel. I have no clue what we're solving for. Minimum coefficient of friction. So multiply both sides by r, divide by v squared. 9.81 meters per second squared. The radius was 2.5 meters, and the speed was 2 pi, and remember that's speed squared. And when you do this, you should get a mu of 0.621. Okay, so it has a fair bit of coefficient of friction, has a fair bit of friction there. All right, so there were all your homework questions. Hopefully you're finding circular motion fun.